Okay, for this example, we're going to learn how to make an output oscillate between an on and an off state continuously. The first thing we want to do is we want to set up our output with a label. If you look at the tabs at the top, there's one called Input-Output Names in the middle. If we go to that tab, we'll have a list of all of our inputs and outputs, and we can actually make custom labels for all of these. The ones on the left we can't change. Those are actually the names of the input and output. But we can change the name on the right by double-clicking in this box. And since we're going to be making an oscillator, we're just going to name this output oscillator. And press enter. And we'll actually have to click the apply button in the bottom to make that change have effect. So I click OK there, and I can go back to my formulas tab. And when we make a new rule this time, it'll show us all of our input and output states, but it'll show our new label for our output, which we named oscillator. So to make this output oscillate between an on and off state, what we want to do is whenever this is off for a period of 1 second, we want to turn it on for a period of 1 second. And we can do that by using this field on the right. This field is for the duration that an input or output has been on or off for, and it's in milliseconds. So if we put in 1000 over here, that means whenever this output is off for 1000 milliseconds, then this is going to trigger an action. And the action that we want to trigger is we want to turn on that same output for 1000 milliseconds here. So if we click OK and apply that rule, we can go up to the simulation, and we'll notice that the output is oscillating between an on and off state like we wanted. And what we can do with this is, if we change the durations for the on and off state, we can actually come up with different blinking patterns that we want. Let's try that right now. If we edit this rule and change the is off value to 2 seconds and make it turn on for 4 instead, then when we go back to our simulation, you'll notice that it stays on for a longer period of time and it stays off for a shorter period of time. On the right, you'll actually see the timer for how long an output or input has been in that state. So when it's off, it'll count up to 2, and when it's on, it'll count up to 4. And since none of these inputs or outputs are changing, they just keep counting up because they've been in the same state for a long time. Now suppose we want to control this oscillator with an input. What we can do is, if we go back to our rule, and let's go ahead and change it back to a period of 1 second for both sides. So to control this with an input, what we want to do is invert the logic on it, so that when the oscillator has been on for 1 second, we'll actually turn it off for 1 second. And the reason we want to do this is that when the simulation starts up, all the outputs are in an off state. So it's going to be in an off state to begin with, which before that was triggering the turning on of the oscillator. Now it won't turn on until we actually turn on this output once. We can actually manually control that from here. So we can see once we've turned it on, it keeps going. So now all we need to do is set up an input to control that. So we can make a new rule, and we can actually use the one that we did for the first example. We can control the output with the singular input by saying, okay, input 1 is active. We turn on, well actually we don't want to use turn on. what we want to... Oh, I'm sorry. My bad. We want to turn on that output when the input's active. And we need a second rule that says when the input is inactive, we turn it off. So now if we go back to the simulation, the oscillator is off to start with, and when we turn on input 1, the output's actually got to turn on as well and start the oscillation pattern. And if we turn off input 1, it'll actually stop. So that means it only oscillates while input 1 is active. For our next demo, we're actually going to look at how to apply these rules to a system to actually get it to do what we want to.